Okay, so I thought I would go over this real quick to show you what we can do. So the test that they're asking for is that we run either a t-test or an ANOVA. Now, we can run this type of test because we can just compare the mean values of each one of our four categories. Remember our four categories of religious importance. We can look at the average value for each of them and then compare them for differences. If you remember our table, there you go, there was a proportion. Each one of these had a certain proportion. Okay, if you remember, here we go. So that was about 10%, 6%, 5%, and 5%. So what we're actually going to be doing in ANOVA is we're actually going to be comparing these averages. And the ANOVA, the null hypothesis, is that there is no difference between these, whereas the alternative is that there is a difference. Now these values are actually off, so don't trust these, but they're close. Okay, because this one's actually 9. This is 9, and this one is 6, and this one is 5, and this one is 5. So let's go ahead and try that out. So first we open our SPSS file. Okay. And in here we have our data view. So you know our data. Let's just go make sure that we have the correct variable at the bottom. There it is. Okay. So let's go and launch some syntax. Okay, so let's start. Let's go ahead and sort our cases by, and we're going to sort them by suicidal ideation. That's the name of the variable. Descending. For whatever reason, your sets require that we do this both ways. I don't really know why this works. Descending. Okay, so okay, and the next is going to be our one-way test, our one-way ANOVA. One way, and then our dependent variable is the H, or I'm sorry, our independent variable is, or I'm sorry, our dependent variable is 1 H, no, suicidal ideation by H3 RE, oops, E30, statistics, descriptives, plot, means, missing, analysis, post hoc, and that should be 2 key, alpha, let's go see what that tells us. Okay, so here we have our ANOVA test. We have our plots, we have our tests of missing. So first let's look at our descriptives, make sure that everything is there. So we've got 700, we've got 1459, we've got the total of 4707. And here's our mean values. What this mean represents is this is the proportion of those who answered yes to those who answered no on the suicide question. So this says that 9.57% that answered yes, it's not important. So as you notice, that's 9.57 yes. And here, this next one is 6.37%, so the percentage is lower, which is what we'd expect. Then it's 5.50%, then 5.47%. Then, and this is just the average amongst all of them. That's not an important value. So we're testing for a difference between these means. Okay, so hope we're on the same page there. Our ANOVA, here it is. So our test, it just tests for the difference between the groups, and then within the groups, our degrees of freedom are once again there 3 for the same reason that the chi-squared is 3. Okay, and our F value is 5.11, and our significance is less than 0.5. So that tells us that our results are significant. Okay, so that's good. Now here are our post hoc tests, and we need these so that we can say, well, where is that difference? So what we're doing is we're comparing not important to each one of the groups. That's why it looks like so many, but you're going to notice that actually half of the results are duplicates. Okay, so we're comparing 0 to 1. Okay, and what we're looking for is here, this value here. If this value is less than 5, then our value is significant. If this value is greater, like this one, then our value is not significant. So if you compare them, you'll want to write them on paper. You're going to notice. So you're saying, is there a difference between 0 to 1? Yes. Okay, and the difference is about that much. Okay, is there a difference from 0 to 2? Yes, and the difference is about that much. This is the difference between the means. Remember, these are the means. Okay, so is there a difference from 0 to 3? Yes, and it's about that much. And as I said, since 0 to 1, notice here, if we go 1 to 0, and it's exactly the same thing. So that's why I said that half of these results are just the inverse or the mirror image of the others. Okay, so once we report, we can go ahead and report these results. Pretty simple, but okay, so let's at least set this aside, and let's go ahead and report. Okay, and so here we would just say something like there is a statistically significant difference between between the groups or categories, you like categories, according to one-way ANOVA. And we usually report the F value here. That's 3,4703 equals 5.111. P-value equals 0.002. Now we report that a post hoc 2-key test shows that the mean portion of suicidal was significantly lower among those who reported religious as okay, and that is somewhat important. There we go. That's the mean value up here. That's 0.0637, and then plus minus, and that's the standard deviation, 0.2444, and then the p-value, we get that from our 2-key test. So we say p equals 0.023. Very important. Oops, I need to put quotes here. Okay, very important. Let me go back up here again. Okay, and that's 0.0550. And then we say once again, plus minus, and that is 0.2280, and that p-value is 0.01, yeah, 0.001, okay, and more important than anything else, and that mean value is 0.0547, 7 plus minus 0.227665. Okay, and P equals, back down here, 0.027. Okay, so, okay. Oh, well, I need to compare it to who I'm comparing it to. So a post-hoc two-key test shows that the mean proportion of suicidal ideation was significantly lower amongst, so we're showing the people who reported lower, okay, than those who reported religious faith as not important. And once again, we go back up to the mean, and that is 0.0957 plus minus, okay, 0.2994. Oh, and that is a p-value of, well, no, we don't actually need the p-value for this one because that's not being compared by itself. We just compared the others, so that's the only one that doesn't need the p-value. Okay, and that's our results. So I know it sounds complex, but if you read it again, now you'll see. So we're saying there is a statistically significant difference between the categories according to one-way ANOVA. And this is what one-way ANOVA does. It just tells us there's a difference. So there's two parts to it. There's the ANOVA, and then there's the post-hoc test. And the post-hoc test tells us the differences between each of them. Now, we can actually run 4, 3, 2, 1, 4 times 3 is 12, 24. Yeah, we can run 24 tests, but we only need these tests. So the only differences we wanted to compare it to the people who it's not important. So it says that the ones were somewhat important. Here it is. There's a difference between them and them. Very important between them and them. We give the means. As you can see, the means are, this is the highest, this one's the mid, this one's a little lower, and this one's a little lower. Okay, and the p-values. So that's all we need to report. Now, the reason that I still like the logistic regression is because, as you can tell, this only tells us a difference exists. The logistic regression will actually tell us how to predict future differences. It's more powerful. So this is a limited test, but it will answer your question exactly. Okay, so I hope that helps. Everything else you can build around it. So in the meantime, what I really suggest is you understand what happened here. Okay, and I know that now that I leave it here on your paper, you'll be tempted to just don't do anything with it, but you should really try to reconstruct this yourself, because ANOVA is not easy. It's quite troublesome, and the whole language of it, I'll leave you a link so that you can see more, because there's a couple of good links. But the point is, though, I hope this helps, and let me know what you think, okay? Okay, take care.